Welcome to Arsenal, where the weapons and war machines of military history come to life. Today, we explore the High Mobility Artillery Rocket System, HIMARS, in Ukraine in 2022, and the crews and opponents who gave it its reputation. If you enjoy learning how technology, tactics, and human decisions come together in combat, you can find more articles, podcasts, and resources at trackpads.com. It is past midnight in eastern Ukraine, and the sky is clear enough to navigate by the stars. A single six-wheeled truck rolls forward with its lights blacked out along a rough farm track that did not exist on any map a year ago. In the cab, 3 soldiers ride in tight silence while the engine hums under their boots. The driver watches the dim red glow of the dashboard and the narrow cut of road ahead. Beside him, the crew commander studies a tablet full of satellite imagery and grid coordinates that turn farm fields into a strike plan. Behind them, the boxy launcher of the High Mobility Artillery Rocket System, HIMARS, rides low and quiet, outwardly just another cargo body, until it lifts and opens. They ease to a stop in a tree line on a slight rise that gives the launcher a clear arc over the horizon. The target is a Russian ammunition dump and command node more than 60 kilometers away, a distance that once meant comfortable safety for rear area troops. Tonight, that range is simply a number in the fire control system. The launcher rises on hydraulic arms and slews toward its firing azimuth with a soft mechanical whine that the crew hardly notices anymore. Inside the cab, the gunner confirms the grid, checks the fire mission data one last time, and arms a pod of rockets whose guidance will steer them to within a few meters of their aim point. Arsenal is the Friday feature of Dispatch, U.S. military history magazine. The firing sequence is fast and violent. Rockets leave in a sharp ripple, each one blasting away into the darkness with a blinding flash and a rolling roar that rattles the cab windows and thumps in the crew's chests. The night horizon ahead briefly strobes with flame before falling dark again. Before the last shockwave has finished echoing across the fields, the driver already has the truck in gear. The launcher lowers as they move, and within minutes, HIMARS is gone, slipping back into the web of side roads and sheltering tree lines that hide it from enemy eyes. For the crew, this is simply another mission in a long pattern of shoot and move that keeps them alive. Far away, at the end of those arcs, the results begin to unfold. First come pinpoint flashes as warheads strike ammunition stacks, fuel tanks, and command buildings laid out in what had seemed like safe order. Then secondary explosions swell and multiply as stored shells and rockets cook off in chaotic bursts that light the night sky. Command posts go off the air, radios fall silent, and units that depended on that hub suddenly find their plans torn apart. In an instant, one truck and one pod of rockets have changed the shape of a fight the crew will never see directly. The men in the cab will hear about the effects later in short, flat reports and brief acknowledgments. Then they will be assigned the next grid. This single night strike sits inside a much larger story. The campaign in Ukraine has seen many such launches, each one chipping away at stockpiles, bridges, and headquarters that supported the Russian front. Yet the roots of HIMARS stretch back decades, to a time when armies were wrestling with an older generation of rocket artillery. During the late Cold War, the United States Army relied on heavy tracked launchers like the Multiple Launch Rocket System to saturate large areas with unguided rockets. Those vehicles could deliver enormous firepower, but they were cumbersome, demanded heavy transport and thick logistical support, and were difficult to move quickly by air to a crisis far away. Their strength in massed salvos came at the cost of agility. As conflicts shifted after the Cold War, those limitations grew harder to ignore. Operations in distant regions demanded rapid deployments instead of slow buildups, and threats became more dispersed and fleeting. Commanders wanted a different kind of rocket artillery, one that could roll off a C-130 cargo aircraft, drive under its own power on ordinary roads, and still fire the same family of rockets and tactical missiles as the heavier tracked launcher. They wanted deep strike range without dragging an armored brigade's worth of support into theater. They needed a system that could support light infantry, airborne units, and marine forces that prided themselves on moving fast and operating from austere bases. The old model of heavy rocket battalions alone was no longer enough. At the same time, technology was making a quiet revolution possible. Advances in satellite navigation and improved inertial guidance meant rockets no longer had to be crude area weapons. With GPS-aided guidance and better onboard sensors, a single rocket could be steered onto a specific building, a bridge span, or an air defense radar, instead of blanketing an entire grid square with fragments. That accuracy promised fewer civilian casualties and less wasted ammunition, but only if the launcher could reach the right firing positions in time. Precision needed mobility to matter. It was no longer enough to have powerful rockets if they were tied to hulking chassis that required convoys and long preparation. These pressures led to a focused design question that blended tactics and engineering. Could a medium tactical truck carry a single pod of rockets, protect a 3-person crew in its cab, and still handle the stress of repeated launches? Could it shoot from deserts, mountains, and cities, then move again before enemy counter-battery fire or drones found it? Designers also had to ask whether such a system could keep up with airborne brigades, marine expeditionary units, and other light forces, instead of lagging behind like a traditional heavy launcher. The idea was to trade some armor and onboard ammunition for speed, reach, and the ability to be flown almost anywhere. HIMARS emerged as the answer to that problem. It is a wheeled precision rocket artillery system built to put long-range, high-precision firepower into the hands of units that could never have dragged a tracked launcher into their operations. Its creation reshaped how the United States and its partners thought about long-range fires, turning what had been the specialty of heavy formations into a tool that light and medium forces could call on. Over time, launchers deployed to deserts in Iraq, rugged terrain in Afghanistan, and training grounds with allies who saw the appeal of that mix of reach and mobility. By the time rockets were flying over Ukrainian fields, the basic concept was proven, and the world was watching as one more midnight salvo showed what a single truck and a single pod of guided rockets could do. The midnight salvos and burning depots only happened because someone first turned a simple idea into a working machine. HIMARS had to give light and medium units the reach of a heavy rocket battery while still behaving like a truck that could go almost anywhere. That design story is about solving a mobility problem without surrendering firepower. Engineers and artillery officers worked together to translate that problem into metal, hydraulics, and software. They kept at it until a launcher that lived on paper became a launcher that could roll down a ramp and into combat. From the start, the team chose a medium tactical truck as the backbone, not a tank chassis. They took a 6x6 vehicle already proven in service and designed a way to bolt a single rocket pod and its launcher mechanism to the back. They integrated the fire control electronics into the cab so that the crew could drive, aim, and fire from one protected space. That choice meant accepting trade-offs. The system would not carry thick armor or crush through swamps like a tracked vehicle. In exchange, it would be lighter, faster on roads, and easy to load into a C-130 cargo aircraft. Each trade-off had to be tested in detail. A wheeled chassis brought lower weight, cheaper operating costs, and easier road marches over long distances, but it also limited how much recoil and launcher mass the frame could safely handle. Carrying only one ammunition pod instead of the twin packs seen on the heavier multiple launch rocket system, MLRS, reduced the immediate volume of fire. However, that sacrifice kept the launcher within strict weight limits for tactical airlift. Designers made it a priority that the new truck should still fire the full family of rockets and tactical missiles already in use, from older area effect rockets to modern precision-guided rounds. That compatibility eased logistics and gave commanders confidence that HIMARS would fit into existing ammunition stocks and battle plans.
At a glance, HIMARS is a high-mobility artillery rocket system built for the United States, intended mainly for Army and Marine forces that rely on rapid deployment. It belongs to the late Cold War and post-Cold War era, with design work maturing in the 1990s and operational fielding in the early years of the 21st century. A typical crew consists of 3 soldiers in the cab, responsible for driving, operating the fire control system, and commanding the launcher. The primary armament is a single pod that can hold either 6 guided rockets for precision strikes at tens of kilometers, or one larger tactical missile for deep targets at far greater ranges. As wars in Iraq and Afghanistan underscored the value of long-range, precise fires from systems that could self-deploy on ordinary roads, production of HIMARS ramped up and more units received the launcher. Seen from the outside, HIMARS looks like a slightly oversized tactical truck with a rectangular box mounted on the back. The truck chassis provides 6 large wheels, high ground clearance, and a suspension strong enough to carry the launcher and ammunition pod across rough roads and dirt tracks. The cab seats 3 in close quarters, with blast protection and armor kits on later models to improve survivability against shrapnel and small arms fire. From this small, protected space, the crew can drive, aim, and fire without stepping outside once the vehicle is in position. That enclosed operation matters in a world where counter-battery radar and drones can detect a stationary launcher in minutes if it lingers. Inside the cab, jobs are clearly divided. The driver sits to one side behind a conventional truck control layout, focused on keeping the vehicle on the move and getting it in and out of firing positions quickly and safely. Next to the driver, the gunner manages the fire control system, entering target coordinates, selecting ammunition types, and running through safety checks on a computer display. Behind or beside them sits the launcher chief, the crew member responsible for overall mission control, communications with higher headquarters, and the final decision to fire. Intercom headsets and radios keep the 3 talking quietly, even when the engine is roaring and the launcher is moving, which keeps coordination tight when seconds matter. Behind the cab sits the heart of the system, the launcher module and its ammunition pod. The pod is a sealed box loaded at the factory or depot with rockets or a missile, designed so that crews in the field never handle individual rounds. A resupply vehicle brings fresh pods forward and uses a crane to swap out empty ones, allowing a full reload while the crew stays under armor. That approach reduces the time the launcher must sit exposed in one place and cuts down on dangerous manual handling of heavy, explosive rockets. When the crew receives a fire mission, hydraulic systems elevate and rotate the launcher, and the fire control software calculates the exact angles and timing needed for the rockets to follow their programmed paths to the target. Beneath all of this, the truck carries a diesel engine, transmission, and fuel tanks sized for long road marches between firing zones and resupply points. The wheeled layout means HIMARS can use the same road network as other tactical vehicles, blending into convoys or dispersing alone into small farm lanes and desert tracks. It trades the heavy armor of tracked launchers for speed and range, trusting instead in camouflage, rapid shoot-and-scoot tactics, and modern warning systems to keep it alive. For the crew, living with the weapon means long hours cramped in the cab, constant attention to navigation and communications gear, and careful planning of every movement. They know that a short burst of rocket fire can bring distant enemy guns or aircraft hunting toward their last firing point within minutes,
which makes every choice about where to stop and where to drive next a matter of survival. Those long hours in the cab and the constant planning only make sense when the launcher rolls into real combat. The high-mobility artillery rocket system first drew blood in the conflicts that followed the attacks of September 11, when United States forces needed to support dispersed troops in Iraq and Afghanistan with long-range firepower. Early combat missions saw launchers rolling out to dusty forward operating bases, where crews fired precision rockets against insurgent training camps, ammunition stockpiles, and command compounds that lay beyond the reach of conventional howitzers. Those strikes showed that a single truck, guided by accurate intelligence and satellite navigation, could collapse a targeted complex with minimal collateral damage. Over time, HIMARS became a familiar presence in joint operations, working alongside aircraft, drones, and special operations teams to hit fleeting targets on tight timelines. The system's reputation leapt to global attention with its role in Ukraine from 2022 onward. Ukrainian crews, trained to operate launchers supplied by the United States and partners, used HIMARS to attack ammunition depots, headquarters, and key bridges deep behind Russian lines. Night after night, rockets arced out from unassuming truck positions, landing dozens of kilometers away on logistics hubs that had previously been safe. Railway sidings erupted, command posts went dark, and long, vulnerable supply lines suddenly faced constant disruption. In several offensives, observers traced the gradual thinning of enemy artillery fire and fuel supplies to sustained HIMARS campaigns that made it dangerous for ammunition and fuel to accumulate anywhere within range. On the ground, a typical engagement followed a well-rehearsed pattern. A launcher moved undercover, sometimes along back roads or narrow farm tracks, to a pre-selected firing point chosen for concealment and a clear line of fire. Target data flowed from higher headquarters, built from a mix of satellite imagery, intercepted communications, and reports from scouts or drones. The crew verified coordinates, selected the appropriate rockets, and fired a short, brutal salvo. Within moments, the launcher was leaving, racing toward a new position, while the rockets covered the distance in less time than it took enemy radars to process and respond. The results showed up as burning depots, severed bridges, and enemy units forced to move and resupply under constant, precise threat. Crews and commanders describe HIMARS first in terms of mobility and precision. They value a system that can drive long distances on its own wheels, roll on to standard cargo aircraft, and fit into the same road network as other tactical vehicles. For units that pride themselves on moving fast, the wheeled chassis means the launcher can accompany light infantry, airborne brigades, or Marines without special transport. Guided rockets and missiles give those units the ability to hit targets far beyond the front line, often with a single pod's worth of fire, and then displace before enemy counterfire arrives. That combination of reach and agility has made HIMARS a favored tool whenever commanders need to hold an enemy's rear area at risk without committing aircraft to every strike. Soldiers are just as clear about the system's limitations. Carrying only one ammunition pod means a HIMARS launcher cannot sustain the same volume of fire as a heavier tracked launcher without frequent resupply. In intense fights, that reality places a premium on well-organized logistics and protected resupply vehicles to keep pods flowing forward. The wheeled chassis, while excellent on roads and firm ground, can struggle in extreme mud or very soft terrain where tracked vehicles excel. The launcher's armor and protection are modest compared to heavy self-propelled guns, which leaves it reliant on concealment, distance, and constant movement for survival. As enemies improve counter-battery radars, drones, and electronic warfare, the risk of lingering too long in one place grows sharply. Opponents fear HIMARS for its reach and accuracy, but also study its patterns. They learn to disperse ammunition, harden command posts, and move high-value assets frequently to avoid creating lucrative targets. They push air defenses and counter-battery systems further forward,
attempt to jam navigation signals, and deploy decoys to soak up precious guided rockets. Comparisons with older rocket artillery highlight the trade-offs clearly. HIMARS cannot saturate a broad front with unguided barrages the way some older systems could, yet it does not need to. Its strength lies in making specific enemy nodes, such as bridges, depots, and headquarters, fragile, forcing an adversary to spend effort and resources simply to keep their rear area functioning under constant threat. Over its life, HIMARS has gained most of its new capabilities through changes in munitions and electronics rather than big visible changes to the launcher. Early systems focused on firing both unguided rockets and emerging guided rounds from the same family used by the heavier tracked launcher. As precision guidance matured, the emphasis shifted toward GPS-aided rockets, capable of landing within a small radius of a chosen aim point. That shift turned the launcher from an area suppression tool into a precision strike asset. Software and fire control updates allowed crews to plan more complex missions, integrate with digital command networks, and handle different rocket and missile types without changing the basic hardware. Export interest and allied adoption brought another layer of evolution. Partner nations sought interoperability with their own command and control systems, local communications gear, and logistical chains. That meant integrating national radios, encryption, and sometimes different vehicle support fleets, while keeping the core launcher and pod architecture intact. Some users focused on the system's ability to fire tactical missiles for deep strike missions against high-value targets. Others emphasized guided rockets for shaping the immediate battle area by cutting supply routes and silencing artillery. In each case, wartime experience fed back into training, tactics, and small refinements rather than wholesale redesigns of the launcher itself. When planners talk about the future of HIMARS, they often speak more about new munitions than new trucks. Longer-range rockets, improved seekers that can home on moving targets, and warheads tailored to specific missions all promise to extend what a single launcher can do. As adversaries improve their air defenses and counter-battery capabilities, the need for launchers that can fire from even greater distances while staying hidden becomes more pressing. The basic idea remains the same. It is still a wheeled, rapidly deployable launcher that can fire a family of modular rockets and missiles. Evolution focuses on stretching its reach, sharpening its accuracy, and strengthening its connection to a broader web of sensors and planners. Even while HIMARS remains a frontline system, its influence on doctrine and design is already clear. Armies around the world now study how to integrate highly mobile, precision rocket launchers into their force structures, often pairing them with drones and satellites in a combined targeting network. The system has helped cement the idea that long-range fires are not only the domain of aircraft or heavy artillery divisions, they can also belong to nimble brigades that operate far from large supply bases. Exercises and real operations show commanders designing campaigns around the knowledge that key enemy nodes can be struck quickly and accurately from well behind the front line, which reshapes how they think about logistics, air defense, and command post placement. For students of military history, HIMARS offers a living case study in how technology and doctrine evolve together. Unlike many arsenal subjects that rest behind museum ropes, this one can often be seen in current training footage and public demonstrations. Launchers appear in live-fire exercises, joint drills with allies, and official displays that highlight their shoot-and-move profile. Over time, retired examples will find their way into museums and collections, where visitors will be able to walk around the trucks, peer into the cabs, and see the launcher pods up close. Those displays will sit alongside earlier rocket artillery systems, allowing visitors to trace the path from massed, unguided salvos to pinpoint strikes from a single-wheeled vehicle. Within the broader ecosystem of dispatch features, the story of HIMARS connects naturally to stories about the units and campaigns it has shaped. Beyond the Call profiles may feature soldiers who worked under the cover of its rockets or depended on its strikes to break enemy resistance. Living history interviews with artillery officers, logisticians, and allied partners can give voice to those who planned and executed the missions that made headlines. Other arsenal pieces on traditional tube artillery, air-delivered precision munitions, and earlier multiple rocket systems form a backdrop for understanding where HIMARS fits. Together, these stories turn a single launcher on a truck chassis into part of a larger narrative about how modern armies fight. In the end, the high-mobility artillery rocket system is more than a boxy launcher on 6 wheels. Every button press in its fire control system sends destructive force toward real people on the other end, whether they stand near an ammunition dump, a bridge, or a command post. The ultimate measure of the weapon lies in how it changes the lives of the crews who operate it and the opponents who face it, sometimes without ever seeing it. Its rockets alter campaigns, but they also shape memories, doctrines, and future designs. For listeners who want to follow those stories further, narrated versions of Arsenal features form part of the Trackpads podcast feeds and Dispatch audio editions, where the machines and the people around them continue to speak long after the last rocket's smoke has faded.